Okay. So here we came up with a scenario, and the whole goal is basically to take this equation, find out by varying the inputs, a 4-bit input where you have A, B, C, D. Any combination gives us either a 0 or a 1 on the output. A 1 means that once we simplify this and build the circuit according to the simplified equation, if the LED is on, the output is a logical 1. If the LED is off,
0.
It's a logical 0. So how do we check it once we assemble this? Well, we're going to start off with the first combination. Just don't do it, just have some sort of strategy. Start with the first one. So 0, 0, 0, 0. How do I get 0, 0, 0, 0? I'm going to explain the details when we do the labs, but let's just say that the 4 switches are off. That means I have a 0, 0, 0, 0. Let's just say it's not working, because it's meant to be a 1, right? If we go back, it's meant to be a 1. Let's just say it's not a 1. How do we troubleshoot? Well, I want to know what the voltage is at every pin. If A is a 0, the output should be a 1, which means the input of the AND is a 1. If C is 0, inverted is a 1, which means the input here should be a 1. So 1 and 1, the output of an AND is a 1. That's tied to the input of this AND, which is a 1. Since I'm tapping off of these two, I can also put a 1 here and a 1 all the way here. I also have a B, which is a 0, inverted to a 1. So I have 1 and 1, output 1. That 1 is tied to the input of the next AND gate. 1 and 1 is 1. Here I'm missing 1. I have a D, which is 0. 1 and 0 is 0, so I'm entering pin 1 of the OR with a 0, but pin 2 is a 1.
1 plus
So
0.
0 and 1, the output is a 1, which means that this LED here should be on. But if it's not, how do you troubleshoot this? What you're going to do is you're going to use your voltmeter. You're going to put it on voltage, right? Put the dial on voltage, positive and negative. Now on your board, right? This is your board. You have your negative and your positive. So this is your negative on your board. This is your positive on your board. What you're going to do is you're going to take the negative and go and rest it in the banana lead. Okay? And then you're going to take the positive lead and you're going to start by following this. You're going to start with pin 1. What are you meant to get in terms of voltage on pin 1? If it's a logical 0, I get 0 volts. Okay? Now, once that's established, I'm going to move on to pin 2. What's my voltage on pin 2? 5 volts. 5 volts because it's a logical 1. 5 volts. And if I move it to here, also 5 volts. Then I start over from here. 0 volts, 5 volts, 5 volts. Knowing as well that it's an AND, if I have 5 volts and 5 volts, the output should be 5 volts. Knowing I have 5 volts on pin 3, there's a jumper going to 4. Visually check it as well. Make sure it's going to the right place. 5 volts. Go to pin 5, where it's coming from D, and D is off. That's 0. 1 and 0, knowing it's an AND gate, 0. This wire 6 is going to 1 over the 32, 0. And then you do the rest. Okay? So if there's ever a discrepancy, you either made a mistake with your wire, or your wire is not in properly. You got to make sure that when you skin the wire, you skin it long enough. Because if it's not long enough, you're putting insulation inside the hole. The hole is made up of 2 metal plates. If you put something in, like the insulation, the copper is not touching. Okay? That's going to give you a bit of a strange reading, 1.2 volts, because it's not grounded and it's not getting 5 volts either. Okay? So that's going to be something else I'm going to be explaining today before I give you the lab. But everyone's